Welcome to today's brand origin deep dive. You've heard of the product, sleek, powerful, seemingly designed to just work. But do you know how a years-long dependency on a corporate partner quietly frayed, sparking an internal project so secret it felt like a technological declaration of independence waged in the shadows? If you find value in this kind of storytelling, consider liking the video and subscribing. It helps more than you know. Let us know in the comments where you're watching from or what you think of this brand's evolution. Let's dive in and discover how it all began. You walk into a restricted section of a corporate archive, the air thin and cold, smelling faintly of ozone and old paper. Dust motes dance in the single shaft of light cutting through a high window. Row upon row of sealed boxes and defunct hardware stretch into the gloom. You're not looking for a product. Not really. You're searching for a secret. The moment a dependency turned into a declaration of war, waged in silicon. This space feels like a mausoleum to forgotten projects and quiet corporate battles. Here lies the physical detritus of Apple's long-standing reliance on Intel chips, a relationship framed internally not just as a partnership, but a vulnerable dependency that chafed. You find a box, unmarked, save for a faded internal project code, P7. This code, as whispered memos confirm, belonged to an early, highly speculative internal initiative aimed at exploring alternatives to their primary processor supplier. Inside, a single unfinished circuit board, unlike anything you've seen, sits beside a hastily scribbled note and a small, tarnished metal pin, shaped like a stylized, broken star. The pin feels strangely heavy in your hand, a quirky, almost melancholic symbol used internally by the P7 team. This isn't just technology. This is where something began to die so something else could live. Brand historians still debate whether Apple fully grasped the strategic leverage they were surrendering when they first embraced Intel's architecture, or if it was seen purely as a necessary step for performance parity in the mid-2000s. The emotional intensity here is one of quiet tension and historical unease, rooted in the perceived power imbalance and the seeds of discontent sown long ago. The unfinished board and the broken star pin aren't just artifacts. They are harbingers of a coming separation, hinting at internal projects that questioned the Intel roadmap years before any public hint surfaced. Building on what came before, the Apple-Intel partnership, for a time, seemed like a match made in tech heaven. After years of struggling with their own PowerPC architecture, falling behind Intel's rapid advancements, Apple made a bold move in 2005, transitioning their entire Mac lineup to Intel processors. This was a major historical milestone, announced dramatically by Steve Jobs at WWDC, promising faster computers and the ability to run Windows, which felt almost sacrilegious yet pragmatic at the time. For a while, it delivered. Performance jumped, battery life improved on laptops, and the Get a Mac ads highlighted the functional benefits of the new chips. The power imbalance felt less critical when Intel's trajectory seemed unstoppable. However, buried in the early transition memos is a quirky detail. Some engineers expressed concern not just about performance, but about heat and fan noise, almost immediately after the switch. They missed the relative cool efficiency of the PowerPC G4 chip in specific workloads, an early sign that thermal design would become a recurring challenge with off-the-shelf processors. Analysts continue to question the reasoning behind Apple's initial, seemingly total abandonment of exploring any in-house silicon development for their main computers during the height of the Intel partnership, suggesting a potential overconfidence in Intel's long-term roadmap reliability. Yet, for the public, the Intel era represented a period of stability and performance gains that helped propel the Mac back into the mainstream. As explored in the previous phase, the initial honeymoon period of the Intel partnership eventually faced headwinds. While performance increased generationally, Apple began to feel constrained by Intel's development cycles and architecture choices. A major historical milestone arrived in the late 2010s. Intel began facing delays in shrinking their manufacturing process nodes. Apple, dependent on these new, more efficient chips for their increasingly thin and portable devices, found themselves stuck. This created immense internal frustration and pressure. Remember that P7 project? It never truly died. Its spirit evolved into more serious internal efforts, codenamed and shrouded in secrecy, exploring custom ARM-based designs. A quirky, almost apocryphal detail from this period involved Apple apparently receiving early samples of future Intel chips, only to find them not meeting power efficiency targets, leading to tense negotiations and reinforcing the feeling of being at the mercy of a supplier's roadmap. Brand historians still debate whether Intel could have done anything differently in terms of transparency or customization to retain Apple's business, or if Apple's desire for complete control over their hardware stack was simply inevitable. The cracks were showing, fueled by silicon dependency and a growing realization within Apple that their future innovation depended on controlling the core component, the processor. The shift was no longer a speculative what if, but a strategic imperative. Building on the tensions caused by Intel's roadmap issues, the strategic imperative within Apple solidified. They needed to build their own silicon for the Mac. This wasn't a sudden whim. It was the culmination of years of experience designing custom chips for the iPhone and iPad, and the growing realization that their mobile ARM architecture was becoming powerful enough for laptops and desktops. The decision to transition the entire Mac lineup to Apple's own ARM-based silicon was a massive, company-defining historical milestone. Internally, the project picked up speed, codenamed Kalamata, signifying a shift to something richer and more integrated. While details were tightly guarded, subtle hints began appearing in the macOS code, referencing ARM support for future hardware. A quirky detail that emerged later revealed that early prototypes were literally MacBooks with iPad chips grafted onto their logic boards, looking incredibly awkward, but proving the fundamental concept. Analysts continue to question the reasoning behind the initial public skepticism about whether an ARM chip, typically used in phones, could truly compete with high-end Intel processors in professional desktop workloads. Underestimating the decade of development Apple had invested in their custom silicon, this period marked a significant shift in corporate strategy, moving from a dependency model to one of radical self-reliance in pursuit of performance, efficiency, and full control over their hardware and software destiny. Following the years of quiet development and strategic planning, the transition became public with a momentous announcement. At WWDC in June 2020, Apple officially unveiled their plan to move the Mac platform from Intel processors to Apple Silicon, beginning with their own M1 chip. This was the major historical milestone, the culmination of the journey hinted at by the broken star pin and the P7 project. They showcased impressive performance and efficiency gains compared to previous Intel-based Macs. The first products shipping with the M1 chip later that year exceeded expectations, particularly in terms of performance per watt and battery life, catching many industry observers off guard. A quirky, delightful detail from this launch was the revelation that the M1 chip incorporated elements refined from years of designing chips for devices as small as the Apple Watch, bringing that efficiency expertise to desktop-class computing. Brand historians still debate whether the timing of the M1 launch, coinciding with a global pandemic forcing more people to work from home, artificially inflated its initial success, or if the chip's performance and efficiency benefits would have been equally impactful under normal circumstances. This marked not just a change in processor, but a fundamental rethinking of the Mac architecture and its capabilities, demonstrating the power of vertical integration and tight hardware-software co-design. The shift to Apple Silicon wasn't just a component swap. It was a fundamental re-architecture of the Mac, leading to profound impact across the product line and the industry. The performance leap, particularly on the first-generation M1 chip compared to its direct predecessors, was a major historical milestone, offering desktop-class performance in fanless laptops and extending battery life dramatically. This forced competitors and chip manufacturers to reevaluate their own roadmaps and accelerated interest in ARM-based solutions for traditional computing. A quirky detail that illustrates the depth of the transition was the development of Rosetta 2, a sophisticated translation layer that allowed Intel-based applications to run on Apple's Silicon with surprising speed and compatibility, making the transition remarkably smooth for most users despite the underlying architectural change. Analysts continue to question the reasoning behind the initial slow rollout of the highest-end Apple Silicon chips compared to the M1, wondering if manufacturing constraints or strategic product segmentation dictated the pace. Nevertheless, the success of Apple Silicon solidified Apple's position as a vertically integrated hardware powerhouse, giving them unprecedented control over performance, features, and thermal design across their ecosystem. And now, we stand at the edge of that archive, the dust settling around the relics of a transition that reshaped a brand. We've traced the journey from a necessary dependency through the quiet discontent hinted at by a broken star pin and forgotten project codes, to the bold declaration of independence with custom silicon. The key takeaways? Dependency can be a vulnerability. Innovation often requires radical self-reliance, and controlling your core technology offers immense strategic advantage. The long-term brand legacy isn't just about faster computers. It's about demonstrating the power of integrated design and manufacturing leverage in a way few companies can emulate. The cultural symbolism lies in the idea that even a giant like Apple felt constrained and chose to gamble on their own abilities, proving that stagnation is the real risk, not disruption. The lessons learned are manifold. The importance of long-term vision, the value of relentless internal R&D, and the understanding that a supply chain is only as strong as its weakest link, or its most powerful supplier. It's a story of hardware, software, and the complex dance between corporate giants. It's about technical specifications, yes, but also about strategic foresight and the quiet courage to break from the expected path. And maybe, just maybe, the soul of a brand is never in its product, but in the people, stories, and stumbles that shape it. Building on what came before, you follow a faint signal, a digital breadcrumb trail leading away from the polished presentations and into the overlooked corners of the corporate archives. You find scattered files, documents mislabeled, meeting minutes buried deep within folders about facilities maintenance, the remnants of something deliberately hidden. This is where you uncover the legend of P7. It wasn't just a project, it was a quiet insurgency, a skunkworks operation composed of key engineers and designers, many whose names are now footnotes or forgotten entirely. They worked almost entirely off the books, driven by a deep, almost visceral need for control, for sovereignty over their own technological destiny, not merely incremental performance gains. You can almost feel the rough texture of early prototype boards described in hushed notes, hear the low hum of illicit test labs late at night. Yet resistance wasn't just external. You find evidence of deep internal skepticism, memos detailing significant resource allocation concerns, and unproven methodologies. A quirky recurring motif appears in their sketches and design notes, even a rejected internal logo concept, a broken star, sometimes whole, sometimes fragmented, symbolizing this push and pull between corporate unity and the desire for separation. Analysts still debate the strategic wisdom of pursuing such a risky clandestine project, while simultaneously relying heavily on external partners. The early whispers in these documents speak of unforeseen challenges and escalating external pressures linked to their primary silicon supplier, hinting at the storms gathering on the horizon. Building on what came before, you delve into the story of the person who would quietly shape Apple's hardware destiny, the lead architect behind P7. You find yourself looking through dusty project files, catching glimpses of a mind fiercely dedicated to one thing: absolute efficiency and integration. This architect wasn't just designing chips. They were envisioning an entire ecosystem, a vision so singular, it constantly pushed against corporate timelines and the ingrained reliance on partners like Intel. Their relentless focus, sometimes seen as an obsession, often created tension within the company. The major turning point arrives with a quiet thunderclap, a critical limitation uncovered in Intel's upcoming roadmap. Not a total failure, but a perceived bottleneck that threatens Apple's long-term ambitions. An optional artifact surfaces here, perhaps a fragmented, partially burned report referencing supplier vulnerabilities from this exact period, hinting at the specific issue. This vulnerability serves as the catalyst, giving just enough leverage for the clandestine P7 project to finally be greenlit by leadership, though immense internal opposition still looms. The emotional core of this era is palpable, the architect's unwavering conviction clashing head-on with corporate fear, fear of the massive cost, fear of alienating a powerful partner like Intel, fear of failure itself. You see the broken star motif appear again, perhaps subtly etched onto early silicon wafers or sketched onto worn blueprints, a symbol not of failure, but of this architect's willingness to break from established norms and pursue an independent path. Sensory details emerge from unearthed log files, detailing late-night coding sessions, the quiet intensity of a critical internal presentation, arguing for the risky pivot. Analysts continue to question the reasoning behind provoking a giant like Intel. But for this architect, the path was clear: integration or bust. This was the moment the chip became more than just a component. It became an act of defiance. Years melt into a blur as you follow the hidden path within Apple, deep into the secretive labs where Project P7 takes root. This isn't just about making a faster computer. It's about dismantling the very need for silicon built by anyone else. It's like deciding you're not just going to bake your own bread, but grow your own wheat, mill your own flour, and even forge your own oven. The emotional intensity here is palpable, a mix of pure genius and bone-weary exhaustion. The air hums with servers, and the only sensory details are often the abstract lines of debugging logs or the cold, clinical readouts of thermal reports. The pressure is immense. The threat of cancellation hangs like a perpetual storm cloud. Technical hurdles aren't just speed bumps. They're towering mountains requiring entirely new climbing gear. You see the broken star motif appear not on a logo, but in the microscopic, intricate dance of circuit traces across silicon diagrams, a visual representation of the complex, interwoven layers they're trying to perfect. Brand historians still debate the internal politics of this era, questioning the intense focus on this single, massive undertaking when so many other projects vied for resources. One quirky detail, often forgotten, the early internal nickname for the complex process of getting multiple core designs to sync perfectly was the Kraken, because it seemed to have 1,000 unruly tentacles. This deep dive into silicon isn't just engineering. It's a power shift happening in real time. The P7 team, forging this core technology, is quietly gaining influence, laying the groundwork for immense market disruption years down the line. A disruption that will feel less like a competitor launching a product and more like an earthquake changing the landscape. Building on the intense internal development and the risks taken in the previous phase, you now witness the carefully orchestrated unveiling. Archived press releases and leaked marketing materials capture the moment Project G broke cover. It wasn't a sudden explosion, but a quiet revolution telegraphed with immense precision. The emotional energy shifts dramatically from the hushed labs to the noisy tech world. Initial skepticism is palpable. Can Apple really build chips? Pundits debate, analysts question. Apple's response is notably restrained, a quiet confidence radiating from their keynotes and press kits. And then, the eerie silence from Intel. Not a counter-announcement, not a dismissive remark, just quiet. Then the benchmarks drop, and they shock everyone. Suddenly, Apple isn't just a company that uses the best technology, it's a company that builds the foundational tech itself. This subtle shift marks a profound change in their public identity. Look closely at the launch materials. The broken star motif appears, perhaps subtly etched on the internal packaging or used in confidential promo visuals. Now clearly symbolizing not brokenness, but a deliberate splitting off, charting a new, separate path. You can almost feel the unique texture of the new machine's box, hear the distinctive boot chime, see the clean visual language of the launch campaigns. Analysts continue to question the reasoning behind Intel's initial muted response. Was it strategic calculation or genuine shock? A lesser-known detail, early leaks of product photos showed slight distortions in the broken star logo, initially dismissed as a render error, but later confirmed as part of the specific material finish designed to catch light uniquely. This moment is the pivot point, foreshadowing the long-term consequences that will reshape the PC industry and solidify Apple's control over its hardware destiny for years to come. You stand back from the archives, the light outside fading. The story of P7, of the broken star, isn't just about faster chips or longer battery life. It's a story about vulnerability, turned into weaponized self-reliance. Apple didn't just replace a component. It severed a dependency, redrew the map of its own future, and in doing so, fundamentally altered its relationship with power, control, and the very definition of a computer company. The cost was immense, measured in years of secrecy, internal battles, and the quiet sacrifices of those skunkworks engineers whose names are barely remembered. The broken star motif now feels less like a symbol of fracture and more like a constellation, a new arrangement of power in the tech firmament. But as you leave the archives, the question lingers. In gaining this unprecedented control, in killing its dependence, did Apple simply create a new kind of vulnerability? Is absolute control the ultimate strength, or merely the most intricate cage? The humming server stacks you pass on the way out seem to hold their breath, waiting. This is the legacy, not just performance numbers, but a testament to the psychological cost of freedom, and a chilling reminder that every act of creation is also an act of destruction. The story doesn't end here, it waits. So we stand at the end of this particular arc, the story of Silicon, the journey inward. It's more than just processors and performance benchmarks. It's about a brand that chose to forge its own path against immense odds. As we've seen throughout this narrative, from the initial whispers of discontent to the broken star phase of intense development, this transition wasn't merely a technical project. It was an existential declaration. It demanded immense courage, blind faith from the engineers toiling in secrecy, and the willingness to potentially alienate powerful partners. The key takeaway here isn't just the raw performance boost you feel when scrolling through apps on a modern device or compiling code on a new laptop. It's the strategic depth this move unlocked, the unprecedented ability to iterate faster, integrate hardware and software seamlessly in ways few competitors can replicate. The long-term legacy is this potent blueprint for self-sufficiency, a model many in the industry now watch with a mix of admiration and apprehension. The cultural symbolism endures, that sometimes the biggest, most disruptive risks lead to the greatest rewards. But those rewards often come with hidden costs, scars left by the struggle. This saga reminds us that even the most powerful global brands are built on moments of intense vulnerability and the quiet grit of countless individuals. It teaches a lesson about the often unseen price of true independence in a deeply interconnected world. And maybe, just maybe, the soul of a brand is never truly found solely in its shining products, but in the people, stories, and stumbles that shape its enduring journey.